Good afternoon, everyone, or good morning, depending on where you're attending this webinar from. First and foremost, I would like to thank you all for taking time out from your schedules to attend this webinar. Welcome again. Today's topic, Test Jig for Smart Grid, Smart City, Wireless RF Communication Modules. Modern smart meter projects demand integration of submodules providing wired and wireless connectivity. This includes smart communication modules supporting various physical layers, including RF wireless. It is important to have a test mechanism to ensure that the functionality of individual submodules is not affected during the manufacturing process. This calls for a production test jig to specifically test hardware functionality and interfaces meeting specific quality needs. Manually testing individual products will be a challenge in case of large volume manufacturing. This webinar explains how Kalkitech can help OEMs in developing custom test jigs and achieve faster manufacturing cycles, thus ensuring proper integration of the various components. A brief on Kalkitech. Kalkitech has long been an advocate of open standards and standards-based communication to facilitate interoperability in the true sense. Our services and solutions enable customers implement mission-critical applications across the smart grid solution spectrum, ranging from substation automation to wide area monitoring, distribution automation to advanced metering infrastructure. To introduce myself, I'm Gautam, and I take care of Europe and Latin America business for Kalkitech ASC offerings. AC being the US-based company we acquired in 2014-15. A few points to keep in mind before we start off. Since we have a large number of participants, this is a listen-only webinar. However, to facilitate clearing of your doubts or queries that may arise during the course of the webinar, feel free to send us your questions by typing in the window provided during the talk itself. We will try to address most of your queries here or come back to you individually in case we run out of time. The presenter talk would be for 40 to 45 minutes, followed by questions selected at random. I would now like to introduce you to our panelist for today's webinar, my colleague, Mr. Vinod Stanley, AVP, who heads the Hardware Development for Services Division. He has over 16 years of industry experience designing embedded hardware and communication solutions for the energy industry. His core areas of expertise include hardware design and development in embedded, digital, and analog domains, EMI, EMC compliance, etc. Vinod has been actively involved in design and development of various hardware products, including embedded data concentrators, industrial gateway computers, system on module, communication interface cards to cater to various industry requirements. Without any further ado, I would now pass controls to Vinod, who will take it forward from here. Over to you, Vinod.
Oh, thank you, Gautam. Hello all. We will go into the webinar. So, as introduced by Gautam, like the modern smart energy products demand the integration of submodules, including wired and wireless connectivity. As a case, take the case of a smart meter. If they want to implement an RF connectivity to the meter, the most easy solution is to integrate with a ready-made OEM solution of RF module. And the power backup, everything can be bought out from them. So in that case, the meter vendor needs to build an interface card which needs to be fit into that smart meter. For that, like after the integration, when it comes to production, there will be a lot of factors which need to be tested to ensure that the module works as per the specifications. That it may include the voltage, current which is being fed for the OEM module to work, as well as the RF power, RF connectivity, the module should work, as well as the communication between the interface card to the meter. For measuring all these systems and to make sure that it works well on all the productionized unit, it is good that we should have a mechanism. The manufacturing volumes, it can be huge, and testing all these modules that can affect the product schedule. Like, like the production schedule, it can be from lakhs to millions. And this additional testing time for this communication module will increase it. So it's anyway better that we should have a mechanism so that the functionality of each submodule, each add-on card in which the additional feature is implemented is introduced and measured so that it doesn't affect the manufacturing schedule. The successful running of any PCB mass production and testing depends upon how efficiently and accurately the PCBs are tested, and it should be ensured that no modules which are failed or has got problems in the production should not go into the assembly. So the manual testing, if you consider at this stage, that has been a challenging task for a lot of people because there are a lot of constraints and it requires the resource expertise to evaluate each and every functionality of the modules before it is being assembled. That will also introduce the manual errors, and all these dependencies need to be avoided. So that will call for the need for the automated testing. The automated testing of this large quantity PCBs within a short span, and it can efficiently cover the requirements of the functional validation. The testing can include the voltage measurement, the current measurement, and there can be functional validations like the modules will be having a power up sequence, power down sequence, transmit power, and communication, the communication with the module, with the meter, and with the different meters and with the different subsystems. For example, if there are wireless modules, the RF power measurement becomes a critical factor because we should have a mechanism that the produced or manufactured modules is effectively transmitting the RF, and so that it can be heard or listened by a far off. So this requirements call for the requirement of the automated testing equipment. So to briefly explain what an ATE or automated tested equipment is, that it's a machine which will be customized and it is designed to perform the test on devices, which can be referred to as the device under test or any product. This ATE uses the control systems and automated information technology. So the control systems can be any hardware or any circuitry which is specially designed for evaluating the performance of our device under test. And it has to create a condition which evaluates and performs all the tests and make the measurements from the product under test. The different features that an ATE requires are repeatability. If we test the module again and again, it should be repetitive. It should give the same result. The accuracy, it should be able to measure and evaluate the readings like voltage, current, power, and it should be able to accurately record it, and it should be displayed to the UI so that the operator will be able to understand whether the module which is being evaluated has actually passed or failed the test. The efficiency, we have a limited time, we have a lot of tests to perform, so everything has to be performed in an efficient manner. Testing time, manpower saving, this should save a lot of manpower, and it should avoid the unnecessary hurdles which arise from the manual testing. Minimal intervention of the operator, any operator who even doesn't have the knowledge of the full functionality of the module should be able to evaluate it. So how Kalkitech can help? So Kalkitech provides a lot of customized jig solutions to cater the requirements of the manufacturing as well as the OEMs. What we can do is that for a product, if the case arises to evaluate the behavior, we can review and finalize the test cases. The test cases should be made in such a way that all the functionalities should be covered and should be measured and monitored. So that review, as well as in case if any functionality is missing, that it should be taken care of to include in the test cases. Design the test hardware. There should be a test hardware which speaks with the device under test and measures the value and coordinate with the other measurement systems and subsystems, and it should be recorded to the UI or the computer. So the design test hardware is an integral part which should be customized. Customized UI development. Most of the different vendors require different UI. And in addition to that, there should be a control UI to evaluate and to configure and to make the test and to read the readings. So a customized UI is required. Custom test report. In case like we have a lot of nicks or we have a lot of products, so that will generate a lot of report. But the manufacturers require to have the report in their own format, displaying the most important parameters which is measured, and it should be customizable. We will be able to give the customized report as per the requirement. Operator training to use the ATE. The ATE or the production test equipment which we make should be given to the operator so that he can handle it much easily. So we provide the training. AMC support required for enhancing the features as well as to make sure that everything is in line. The application areas where we can use the jig. The test jig, it is employed in all the products, all electronic products that are produced in large quantities. It can be a communication adapter, any daughter board which can be plugged into different modules or different devices, RF interface module, which are common today to add additional functionality of RF communication. Smart sensors and IoT devices, which are common nowadays, which can be tested with the test jig. Smart meters and DCUs, which are more common, and as day by day, the features are being enhanced into these DCUs and smart meters by adding additional modules, which require to be evaluated for the production. And the test jig can be used to evaluate each and every of the test cases to make sure each of the modules or each of the products being made require or evaluate all the functionalities has been met. What are the functionalities of the ATE? So the ATE basically makes some measurements. Like it can be a voltage measurement, like voltage rise time, fall time, current, power levels, noise and leakage measurements. Certain products demand that the noise and the leakage current in the circuit should be controlled so that the dedicated CPU and the other circuitry is fed with the clean power. So the ATE should have the facility to measure those, as well as there are a lot of modules nowadays coming inside the meter which requires the backup, including the supercapacitor backup. So whatever the productionized unit or the modules come out of the production should be evaluated that the circuit has been soldered properly or the circuit is intact and it performs the required amount of backup uh, required by the functionalities. So this backup functionality evaluation comes as a part of the AT. Firmware testing. The modules which comes in production are evaluated for the firmware. So there will be basically a test firmware in which we load the firmware and it is being evaluated. And after that, the production or the installation firmware has to be loaded. That can be covered as a part of the AT functionality. Again, the functionality verification or the functionality test. The intended functionality of the product should be met before we use it in our final jig. So the power up, power down sequencing, for example, the modules which employ RF require certain timings for the power up, power down, and ensure that in between the required voltage power rails has been powered. So these rails or these power can be monitored, and each of the module can be evaluated that it functions or it meets the required power up, power down sequencing. Communication test like the serial Ethernet RF. The communication test in the meter between the meter and the communications between the DCUs, it should be ensured that it works as per the requirement. It can be a serial communication or an Ethernet communication, or it can be an RF communication. So we make sure with the jig that the module functions as per the requirement and it communicates with the necessary power so that it performs well in the field before the integration. So we will go through the important components what make an ATE. So basically there are two parts. One is the test rack, the other is a test fixture. So the test rack basically will have a test PC. So it will be a high-end PC, and that will employ a data acquisition unit to take the different readings from the NIC or any product which is being tested. The waveform analyzer is another part which analyzes the waveform, and it analyzes the noise, it analyzes the ripples. That will vary upon the requirements from the different vendors or manufacturers. The programmable power supply. It is being controlled from the system to ensure that necessary power, necessary voltage has been fed to the system to evaluate different features, and it has to be turned on, turned off, or ramped up as per requirement. RF power meter will be a part in which the RF power or RF functionalities of the device under test is evaluated. If we need to enter the serial number of the product which is being tested, a QR code scanner can be also implemented. And our rack has got the functionality that the readings or the entry from the QR code or any other multiple entries can be scanned and fed into the system. The other part is a test fixture, which employs a control card, which is the nucleus, or it is the main part which connects the subsystem with the UI. The test holding mechanism. The NIC or the device under test should be properly secured into the system. So that requires a good mechanism so that the operator can easily put the device under test, and it can be properly secured so as to start the measurement. Test probe or the pogo pins are the pins which actually make in contact with the circuitry, take the readings without affecting the functionality of the product, and the readings or the measurements and signals has been transferred to the control card for evaluation. These AT blocks are shown for reference. So basically here a meter interface card, which is an RF interface card, has been shown for reference. So to take the readings here, we have employed different equipments like the power analyzers, the RF meter, and data acquisition card, PC, and the USB interfaces. So going into each subsystem, the main part is the multifunctional DAC or data acquisition device. It is responsible for all data access operations with the device under test, and it functions as per the test case or the test sequence which has been planned. The typical features of the DAC here presented are it will be having minimum 16-bit resolution, and that can vary upon the requirements from the customer. It should be having a minimum sampling rate to make sure that it captures the signals and data from the device under test. The timing resolution should match the requirement, and there are cases which require the analog output. To create a test environment, this requires we should provide some analog output also, and it can be measured or it can be input into that system or device under test, where we can measure the response from the system. One of the solutions in which we have used had 900 kilo samples per second with 16-bit resolution. Digital input output. It is a programmable, and it has got special ESG protection to make sure it withstands all kind of handlings. And the digital input, digital output is connected to the subsystem or the device under test to ensure that we collect all the data, all the current, all the voltage measurements which are required for the evaluation. The programmable power supply, as we mentioned, is an integral part, and it is used to power the device under test. And the programmable power supply is being controlled from the test software to make sure that it provides the necessary voltage at the necessary intervals as required for the application. The power output from all channels can be controlled. There will be multiple channels which has to do the multiple voltage injections to the circuit to make sure that all the test cases are covered, and the channels models required for the project will be selected as per the requirement of the customer. Signal analyzer is used for cases which require the signals to be analyzed and make sure that it functions as per the requirement. One important case which we usually evaluate are the noise level in the power and signal buses. If the components are not at all properly soldered or intact, or a wrong component is placed, that will introduce unnecessary noise, making the system disturbance more severe. So this could be evaluated with a signal analyzer. So here in one of the applications, we have used 100 megahertz, for example, with a minimum pulse detection and maximum sampling rate. It was also having an overvoltage protection to withstand the unnecessary fault which the device under test can introduce to the test equipment. The RF power meter most commonly employed in the test systems which has got an RF module to be tested. So the device measures the RF power transmitted and it ensures that the RF module integrated into the add-on card has been properly done to ensure the correct range is being provided in the end product. There are different cases in which the customers are not at all able to evaluate whether the RF module is properly soldered or integrated in the end product. Here, the case like the power meter selection, it can be a 50 megahertz to 8 gigahertz that can be selected upon the requirement. And it should be having a good dynamic range. The peak or the pulse profile sensing can be done. There are cases in which average sensing or average profile measurement is being done for the customer. The QR code scanner, as mentioned, is used to easily input the QR code, which is pasted upon the PCBs or the products, and that reduces the time the operator spends for noting down the serial number for the against the test cases. The custom control card, which we mentioned as a nucleus, it actually makes interfaces and it coordinates all the activities between the test system UI, different test meters, different test equipments, and it integrates all the signals which is being taken from the NIC. The control card actually connects the DUT to the test PC where we have the UI and other customizations. The control card is custom designed to meet the test case requirement. It has advanced circuitry and it has been designed in such a way that the improved performance and efficiency of the system is covered. It has options like LED for visual indications and buzzer for audible indications in case if the test passed, failed, or a configuration change. Test fixture, which houses or which where we place the device under test, is also an important part. We are designing the test fixture to make sure that the operator can seamlessly place the product for the test, and it is specially taken care that the anti-static and ESG protection is done to make sure that the board which are being tested are left undamaged. And the customly designed test and hold fixture has been a good reputation from the different vendors which we have supplied. The test pins or the pogo pins actually make the contact with the PCBs under the test. So these are the moving pins, and the pogo pins are spring action pins that is widely used in the testing industry, and this captures the different current voltage from the different parts of the PCBs, and it takes it to the control system and to the different equipments for the measurements and analysis, and it will be compared with the required levels to make sure that the board or the device under test meets the requirements. Here in the picture, you can see one product, a PCB, which is a device under test. Looking closely into that, you can see small dots, which are actually the test points where the pogo pin makes a contact. The bottom picture or the second picture actually mentions how the PCB is being placed on the test bed for measurement. Going into the mechanical features of the jig, so it's actually a rugged design and it can safely hold the PCB, the power supply, and all the equipments inside the jig. It has got caster wheels and you can move across the plant as and when required. And you have easy access to the internal device during maintenance and to connection, and everything can be done. The power outlet provided for connecting additional equipment will be there, and the test jig is protected by fuse MCB to make sure that if there is any failure, it is being protected. The anti-static jig fixture, as mentioned before, adjustable stand for fixing the monitor. So the monitor, if you want to fix it, that provision is also there in the as part of the test jig. ESD bench is there for ESG wristband that makes sure that the operator using the jig for the measurement takes care of the ESD, and so the board and the electronic components are not affected. The power plug that can be selected based on the location, if it is US or Thailand or China. I would like to present the case of Kate 100, which is one of the jig we are giving to prominent meter vendors who are using the modules from a renowned RF module manufacturer. So this Kalkitech manufacturing test jig or Kalkitech automated test equipment, which we call as Kate, it is customized to test the network interface card, which comes as a part of meter. So these network interface card add the RF power to the meter, as well as it has got a super cap mechanism to give the power backup mechanisms and the last gas messaging. So there are a lot of test cases which the OEM had asked the vendors to conduct before it is being assembled. Almost some 58 test cases. So these test cases cover each of the functionalities of this device under test, or we call it as a NIC or network interface card. It validates the voltage level, rise time, communications between the different subsystems, RF power level, and it has been employed for the high volume testing. If we manually go for the measurement of each of the 58 test cases, it will take almost more than half a day. And with this test jig, we were able to cover in 60 seconds. And it is successfully deployed in a lot of sites where the NIC integration is going on. So this is the appearance of the Kate or the Kalki automated test equipment. So it has got a monitor and it has got the test fixture, and you can see the test track also along with it. So these are the rack components which give an idea of how we are assembling it, the different subsystems or different measuring equipments. We have taken special care that everything has been mounted properly into the subsystem with the clamping, wire routing mechanisms, everything has been taken care of. Again, it houses a PC inside it, which contains the DAC and which talks with our control card to make sure that everything has been covered. So here comes the test jig, which comes as a part of the test track on which we place the PCB. Also, from the snap, you can see that there are manual mechanisms for the power on, and there are manual mechanisms to start the test, stop the test, and emergency stop button. So the user can operate manually as well as he can operate on the PC through our UI. So this is our UI. We call it as CubeLink. So this UI actually controls or speaks with the PC, and it takes care of all the tests. You can see the login option for the user, and there is a password option. There is an option for the user license, which since this software is licensed, and the update firmware option is there. The second snap is the main window of the UI. Like to start test, we have the start CubeLink option. There is a setting option where we can do the settings. The edit configurations where we can configure the different tests and different parameters as per the requirement. The user management helps us to add the different users as per the requirement. There is a report section which can create individual or the test report, as I mentioned, customized report as per the requirement. We will have a short video on how we will use it later in the session. For user, there will be a super user or the admin who takes care of the complete jigs. So he has the privilege to modify the test limit and the test sequence as per the requirement. He can create the normal user or basically an operator. The operator will not be given all the privileges except testing. So The super user can create as many normal users required with a password. So the normal user can log in when he's doing the test, and his details will be logged into the different test report which is being generated as a part. So here you can see the user 2 has been created, and there are options to enter the username, password, uh, add user, everything is there. Also the provision to delete user is also there. In the report section, currently there are two provisions: individual card report, summary report. Individual card report covers the report of individual NIC or device under test with all the parameters, including the upper value, lower limit, as well as the measured value, and individual status of each test, whether it is a pass or a fail, as well as the final status of the test, whether the overall NIC or overall device under test has passed or failed. The summary report has the provision to generate as many reports as required, which can be selected based on the date or the device's serial number, which is tested throughout. So that will provide a tabular data of the result. Also, there is an option to export the data from the database. This is a sample individual card report. You can see in this case, the OSDA serial number is the serial number corresponds to the module, which RF module, which is placed on the meter. NIC serial number is the PCB serial number where the add-on guard is noted. This is the user who did the test. This is the total execution time. This is the overall result of the test. You can see the individual test parameters which is being evaluated, the lower limit against the parameter, upper limit against the parameter. This lower limit and upper limit can be configured by the administrator. The value which is measured during the test, X unit, and individual result. Since it's 0, it's fail. Individual result of each test, the date. So here you can see the individual card report can be selected by typing the either the serial number or the PCB serial number and open or export. The report upload option in case like we want to upload or take the report from the database. This is a configuration which is available for the administrator, and it is it's a good configuration which is required to edit the test range. There are requirements like within the factory, like we need to adjust the ranges. Like we have a minimum range, we have a maximum range. This range can be configured as per the requirement for each of the parameters. So here you can see that the voltage of the green LED. So that parameter is named as green LED on. So the minimum and maximum parameter can be set. And after we save it, the final results will be evaluated based on these parameters. Also, there is another provision to calibrate the test jig. There are customers who evaluate or who make the test jig measurements based on a reference or a golden card. So they'll be having a card which functions perfectly, which they will keep it as a golden card. This golden card will be loaded into the test jig and it will be measured, and the reference card values will be displayed here. Based on that, they can adjust or calibrate the test jig for the minimum and maximum limit, which will later be used as an evaluation for the remaining units under test. Other options like the buzzer control, it can be turned on or turned to mute, the QR code scanner reading, and automatic or manual testing. There are customers who doesn't opt for the manual operation of the buttons. Instead, they will mention like, we want the test to start once we close the lever. So if the test start option is put to automatic, that will operate. If it is in a manual mode, the other customers, they have to manually press the button or make sure that they have done all the precautions or noted down all the entries before starting the test. So some of the customers go for the manual testing mode. This is the NIC serial number recording in which the QR code scanner can be used. In this case, you can see like a bigger serial number. It will be a tedious task for the operator to record it. So here in this case, we can use a QR code scanner and our UI can accept the scanner readings. So this is how we load the NIC into the test system. So you can see like we load the NIC, we press the lever, and we can start the test. For starting the test, this is a UI which is a part of the kit. So you can see the tests are divided into different blocks. Like here we have a power up sequence which consists of some tests, device communication, like the communication between the meter, output power, basically the RF power measurement, LED status test. Again, power up will be followed by a power down sequence, leakage current. So for each of the tests, we can find like the progress bar displays the status, and you can see the overall result of each of the tests and what is the final result. The card sequence number will be displayed here based on each NIC which we place, and based on each test is complete, like the values are displayed at the bottom part of the screen. Here also there is an option like we can see the summary or individual test report. So I will basically go into the video on how we use the test jig for the operation. So here, as I mentioned, we have a login option and a password option. So you can see like I have logged in as admin and entered the password. So I am starting the cube link option is there. The settings option is there. So it will be having some additional options where we can configure for automatic or manual, and the buzzer option configuration is there. Like I am using the manual entry for entering the serial number. The edit configuration allowable for admin to configure the minimum and maximum limits for each test. Here we have 58 tests in this case. You can see like the 4.5 millisecond maximum, I am editing it to a different value, say 3, and I can save it. And after saving it, it will be configured as a new value, and the balance test will be done based on that. I'm changing back to 4.5 now. This is a user management in which I can configure or change my password in this section. So here, since I am not doing it, I can do, or I can add more users as per requirement. Here I am adding an additional operator here who will be having less privilege only to test it. So enter username, I am entering user underscore test. So I can configure a password for him. Confirming the password, the user is added. So if the user logins to that, he can do as the user underscore test for the remaining systems. I am deleting the user in case if we not required. The report session in which individual card report and the summary report of devices under test can be taken from month to date. So exit. So going back to settings, I am selecting the manual mode. I am saving it. I am going to start the test. So in line you can see the test jig and an operator sitting there. So he's scanning it with the QR code scanner. So it has been entered. So you can see in the inline that the scanned serial numbers are being entered in the UI. He's placing it for test, closing the lever. He's starting it. So the test has started. You can see that the initialization, the power up sequence initialization is going on. NIC health status is going on. For each of the tests, the test progress bar on the right displays the progress. Now for the present test, it is a pass, so it is displaying as green. Super capacitor power up test is going on. So again, that is a pass. So you can see that as the test progresses, the test results are updated at the bottom of the screen. So going to the device communication test, which are the tests with the meter, output power or RF test, LED status test. Now comes the power down sequence. So all the values are being updated. Hence the overall result is a pass. So I'm taking the report from show report. You can see the report has been popped up. We can see the readings corresponding to the OSJ serial number and NIC serial number. Against each of the test cases, we can see a lower limit, upper limit, and the value, and individual test status and overall test status. I'm taking a report summary to show the result of the NICs which has been tested continuously. So here you can see like there are a lot of NICs in which the serial number has not been entered. So that has been displayed up. So here these NICs are having the status overall passed. And if I want to exit, we can exit from the UI. And it goes back to the CubeLink main window. Pressing exit exits the test. So that's all on the Kate and automated test equipment. Thank you.
Thank you, Vinod, for the detailed and informative talk. Let's move on to the questions. So we've got a few questions from the participants.
Okay.
The first question is, can we use the same test jig for different variants of the add-on card for the same product? So if I have an RF module from one manufacturer, I guess that's the question. And if a person moves to a second manufacturer of RF modules, can he use the same test jig?
Okay, that's a nice question. So you see, like for making the measurement, we have to put the NIC or the RF card onto our test bed, and we have to make sure that the test pins make contact with the test points. From the two manufacturers, like since if they are different PCBs which have the different test points, we cannot use it. But there are cases in which, like I can see a manufacturer using the same PCB for his single phase and three-phase meter. So in that case, we'll be able to place it and we can use the same test jig. But for the different PCBs, it cannot be used unless otherwise the PCB dimensions as well as the test points are same.
Okay. The second question is, what is the life of the test pin or the test probe?
We are using all the equipments and all the assembly items we are using are high quality made, and the pogo pins we are making has got minimum 1 million cycles.
Okay. If the third question is, if we redesign the product, that is the device under test, what changes we have to make in the test jig for it to work?
Okay, yeah. So again, something related to the first, like as long as we have the test points and the test PCB dimensions same, we can use that same test bed. So when the different vendors go for a PCB respin, they make sure that they place or they fix the card dimensions and the test points exactly at the same place. But in case if they want to change the parameter of the measurement or the measurement values, like it can be changed, as well as the admin has got a privilege to add it. But there are cases in which without changing the test points, like the vendors will demand adding or measuring more features into the test evaluation or the test cycle. So those features can be added provided we have the option already there in the jig to take the measurement. So if we are using a test jig while we do the respin, it should be ensured that if we want to use the same test jig, we should try to maintain, unless it is not a major redesign, we try to maintain the PCB size and the test points almost everywhere the same.
Thank you, Vinod. I guess those were the questions which have come from the participants.
Oh, okay.
Thank you to all the attendees for taking time out to attend the webinar. If you have any additional questions or queries, feel free to drop us an email at marketing@kalkitech.com and we'll try to come back to you as soon as possible. We will also be sending a recording of this webinar to all the participants shortly. Have a great day and thank you for attending again. Bye.